So let's see if we can find the sum of this finite geometric series. Okay, there's a lot to think about here, right? So let's figure out what we know first. Things with a geometric that we can always figure out. So A1 and R we know are important. So our first term, A1, is 3. What's happening between these terms? So let's see, I think we're multiplying. I like to use green on the steps. I think we're multiplying by 2. So 3 times 2 is 6. 6 times 2 is 12. Yeah, so R is equal to 2. All right. So what else do we know? Well, we know how to write the nth term, right? A sub n is equal to A1 times R to the n minus 1. So A sub n is equal to 3 times 2 to the n minus 1. One thing we have no idea of is what is n for this thing. So we know that A sub n is 1536, but we don't know n. So 1536 is equal to 3 times 2 raised to the n minus 1. Okay, well, we'll divide both sides by 3. We're going to get 512 equals 2 raised to the n minus 1. And I am not sure if you all know how to do logs yet, but you would do log base 2 to figure this out. And if you do log base 2 at both sides, let's see, log base 2, then you're going to get 9 is equal to n minus 1, add 1 to both sides, and n equals 10. All right, so we did a lot of work there and didn't get very far. Yeah, actually we did, but I used up all my space, which is a problem. So for right now, we're going to skip the next one so I can use this space. So now we've figured out that A1 is equal to 3, R is equal to 2, and we just figured out that A10 is equal to 1536, although that was pretty tricky. So now we know that we're looking at a problem where n equals 10, and what we want to find is the 10th term. So we'd really like to know the sum up to 10. All right, so going back to my formula, actually before I write S10, let me do Sn. So our formula Sn is always equal to A1 times 1 minus r to the n over 1 minus r. So now we have a plug and chug situation with n equals 10. So S10 is equal to 3 times 1 minus 2 raised to the n over 1 minus 2. I forgot, I actually know that it's 2 raised to the 10. So that's equal to 3 times 1 minus 2 to the 10th. I'm just going to write it like that because I'm going to put it in a calculator. Over 1 minus 2 is minus 1. So when I put all that in my calculator, my final answer is 3069. We're going to work this next one together also. So just hold on for that. And then we'll work one of the bottom two and you can work the other one. We're not going to do this, and so I'm going to change one thing and we're going to call this n equals 1. I'm going to leave this one for you to work, but we'll do the other one. All right, so here we have this summation, and if I want to use that S sub n is equal to A1 times 1 minus r to the n over 1 minus r, there are 3 things I need to know. N, A1, and r. So n's equal to 10, because that's a sum over 10. A1 is equal to 5, because what we put inside of here is always the explicit rule. And so I recognize the explicit rule as A1 times R raised to the n minus 1. So R is equal to minus 2. Okay, so then I have everything I need to solve. So S10 is equal to 5 times 1 minus 2 raised to the n, which is 10, all over 1 minus 2. And that ends up, after you put it in your calculator, being minus 1705. All right, like I said, we're going to leave that one to do together or to challenge you a little bit.